What's up guys, this is Massey. Welcome to another video. In this video I want to talk about the speed of sound and how to calculate speed of sound. It has been determined experimentally that the speed of sound through air depends on the density of air and its temperature. This value increased by 0.606 meter per second for every increase of 1 degree Celsius. So we can calculate the speed of sound using one of these equations here. Speed of sound equals to 331.4 meter per second plus 0.606 times T. The T is temperature in terms of degree Celsius. And the unit for 0.606 is meter per second per degree Celsius. There's another simplified form of this equation. It is 331 plus 0.6 times T. And there's another one which is 332 plus 0.59 times T. So these three different equations are given in different references. So that's how we calculate the speed of sound in the air. What about the speed of sound in solids and liquid? In general, sound travels fastest in solids and then slower in liquids, and after that is going to be gases. So the speed of sound in solids are greater than the speed of sound in liquids, and the speed of sound in liquids is greater than the speed of sound in gases. For example, the speed of sound in water is almost 5 times faster than its speed in air. Let's do some examples here. First example is saying that calculate the speed of sound at temperature of 23 degrees Celsius. So if we use the first equation we saw, is going to be 331.4 plus 0.606 times temperature. Temperature is 23 degrees, so it's going to be 331.4 plus 0.606 times 23 degrees. So when we calculate it, it's going to be 331.4 plus 0.606 times 23. That's going to be 345.338 meters per second, or we can say approximately 345 meter per second. Let's use the second equation. Second equation was 331 plus 0.6 T. So that's going to be 331 plus 0.6 times 23. And that's going to be 344.8, which is going to be approximately 345 meter per second. And if I use the third equation, 332 plus 0.59 T, so it's going to be 332 plus 0.5923. It's going to be 345.57. This one is going to give you 346 almost meter per second. As you see here, there is not much difference between all these equations. These two equations are very common, so that's why they got the very similar answer here. 345, and here for the third one we got 346 meter per second, which is very small difference. Let's see another example. Now for the second example, calculate the speed of sound at 25 degrees, which is 2 degrees more than the previous example. So I'm gonna use the three equations again. The first one was like that. We just need to substitute the temperature there, which is 25. So 331.4 plus 0.606 times 25. They give me 346.55. This is going to be 347 meters per second. Second one is going to be 331 plus 0.6 times T, which is 331 plus 0.6 times 25. That's going to give me 346 meters per second. The third equation, 332 plus 0.59 times T. So 332 plus 0.59 times 25. Let's see. 347.75, which is going to be almost 347 meters per second. So as you see here, when you increase the temperature from 23 degrees to 25 degrees, the velocity or sound of the speed of sound is going to increase from 345 to almost 347. So as the temperature goes up, the speed of sound goes up as well. Sometimes the speed is given. We need to find out the temperature this time. Let's see another example. Okay, in here it says if the speed of sound is 349 meters per second, what is the current air temperature? So we're gonna say velocity or speed is 331.4. I keep saying velocity, but speed is gonna be more correct name for this part because there is no direction in here. So 331.4 plus 0.606 times t. So the velocity is 349. 331.4 plus 0.606 t. Move it to the other side. 349 minus 331.4, 0.606 t. I moved 331.4 to the other side. Now 349 minus 331.4 is going to be 17.606 t. So t is going to be 17.6 divided by 0.606. It's going to be 29 degrees. So the temperature is 29 degrees. We need to know that if the temperature is positive, the speed of sound is greater than 331.4. If the temperature is negative, lower than 0 degrees, the speed of sound is going to be less than this number. And at 0, the velocity or speed of sound is going to be 331.4 meters per second. Let's see another example. Next example, it says if the temperature of air is 33 degrees Celsius, what is the speed of sound in air at that temperature? So again, we use the first, I'm just going to use the first formula for now. Meter per second plus 0.606 T. Temperature is 33. We don't need to convert it to Kelvin or Fahrenheit or something like that. We need to keep it as Celsius. So 331.4 plus 0.606 times 33. That's going to be 351,398. So which is going to be almost 351 meter per second. Let's see another example. It says if the speed of sound near you is 337 meter per second, what is the ambient temperature? So formula V, 331.4 plus 0.606 T. So you have 337 equals to 331.4 plus 0.606 times T. If we move it to the other side, 337 minus 331.4 equals to 0.606 T. So 337 minus 331.4 is going to be 5.6 equals to 0.606 T. So T is 5.6 divided by 0.606. That's going to be 9.2 degrees Celsius. That's going to be the temperature. Another example. If the speed of sound near you is 360 meters per second, what is the ambient temperature? So that case is going to be 360 equals to 331.4 plus 0.606 times t. We move it to the other side. 360 minus 331.4 equals to 0.606 times t. It's going to be 28.6, 0.606 t. So t is going to be 28.6 divided by 0.606. It's going to be 47 degrees. This is going to be the temperature, ambient temperature, 47 degrees Celsius. Next example. What is the speed of sound in air when the temperature is A, 20 degrees, B, 24 degrees, C, negative 32 degrees, negative 32. So A is going to be V, 331.4 plus 0.606 times 20. That's going to be 343.52 degrees Celsius, which is going to be 344 meter per second. B, V is going to be 331.4 plus 0.606 0.24 times 24. 331.4 plus is going to be 345.944 rounded to 346 meter per second. C is negative 32, so it's obviously the velocity is going to be less than 331.4, so it is going to be 331.4 plus 0.606 times negative 32. It's going to be 312.00 meter per second. So these are the speed of sound in different temperatures. So that's how we calculate the speed of sound in different temperatures. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.